My name's David Weiss. This is my third JuliaCon and Conning's second time sponsoring JuliaCon. So what's a Conning? Conning provides a suite of products and services to the insurance and pensions industries, and I'm responsible for the development of our risk management software product, which is basically a very large-scale, multi-period Monte Carlo simulation of an entire insurance company and the exogenous world in which it exists. So what we're really basically doing is computing a huge three-dimensional array. It's big. It's not as big as cataloging the universe, but it's big enough to throw thousands of CPU cores at the problem. The model itself is very, very complex and detailed, so having an expressive, productive high-level language is absolutely key. And of course, there's the need for performance, and therefore, obviously, Julia is an excellent fit. So why are we sponsoring JuliaCon? Because we think it's important to grow the community. We're proud to enable people who otherwise would not be able to attend to be able to do so. And I want to encourage all of you who have the means to sponsor future JuliaCons. It's important to get the word out, talk to friends and colleagues, speak at other conferences, not just here in the Julia Echo Chamber, and talk about Julia when talking about your work with the media. In all likelihood, if it wasn't for the 2014 article in Wired magazine, I might not be here today. We tend to come to JuliaCon in force. This is about half my team who is here this year. Another thing I do to spread the word is bring in 2 CS interns every summer, exposing them to Julia and bringing them here to JuliaCon. And this year we're giving them the opportunity to not only work with Julia, but to contribute to it. And so the 2 gentlemen at the left in this photo, Alex and Kevin, are this year's interns, and I'm going to turn it over to Kevin for just a brief moment to talk about some of the work that he's been doing with Alex to speed up the implementation of unique in Julia when applied to integer vectors.
So the key thing about basically David's idea for unique was if the range from the smallest integer to the largest in the list that you want to run unique on is not too much greater than the size of the list, then we can allocate a temporary array whose length is equal to that range. For the normal uniques case, that's going to be a bit array, and we set the value of an index in that array that corresponds to a number from our original list to true if we've seen that number before. The charts here show the runtime and memory ratios between our implementation of unique and Julia's built-in unique. You can see a diagonal in the bottom right there where it goes from blue to just white, and that's the cutoff where we switch from this counting sort algorithm to the built-in unique, and we determine that with using benchmark tools. So you can see a little small penalty for determining whether we want to use the counting sort algorithm or the built-in one. But the good news is that for many cases above the diagonal, we see runtime improvements as much as 20 times or more, and significant memory allocation reduction as well.
Okay, so while I'm putting up this slide that my legal and compliance departments require me to put up, let me also say that we are hiring in our quantitative finance group, which works on our economic models. So any of you who have advanced degrees in math or physics or quantitative finance who are interested in applying Julia skills to quantitative finance, come see me. And thank you very much.